No but. Okay, properties of inverse trig functions. Our first property is that the inverse sine of negative x, in other words, the inverse sine function of an angle in quadrant 4, negative x, equals the negative of the inverse function of x. Now, the reason this works, you know, do you remember 2-unit odd function? I'm going to draw, you know how I said that sine x curve? No, the inverse sine x curve looks like the y equals x cubed curve. You know, inverse sine x curve looks like that. Looks like that. Negative 1, 1. It reminds you of y equals x cubed. Right, and that's a 2. So, you know how I said the inverse sine function reminds us of the y equals x cubed curve. Now, that y equals x cubed curve is an odd function. So, this function is going to be odd as well. For an odd function, doesn't function of minus x equal function of, no, negative function of x? That's what that is. Because it's an odd function is not reflected in the line y equals x. That's inverse function. Odd function means if you rotate it around the origin 180 degrees, the graph sits back on top of itself. It's got point symmetry. That's what an odd function is. If I rotate that 180, this point ends up down here, rotating about the origin. That's an odd function. And the other thing with an odd function is that the function of negative x equals negative function of x. Now, we're going to prove this. So if we let y equal the inverse function of negative x, then sine of y equals negative x. Now, this is because the range of the inverse sine function is from negative pi and 2 to pi and 2. Now, I'm going to make x the subject. So x equals what? How do I make x the subject? Good. Which is negative sine y. Isn't that the sine of negative y? Because sine in quadrant 4, you know, in quadrant 4, sine is negative. So let's say sine of negative 30, for example, is negative sine 30. What's sine of negative 30? It's negative a half. It's normal sine function, all stations to central. Sine is negative in quadrant 4. That is the same as negative a half, or negative sine 30, which is negative a half. So here, if I've got negative sine of y, that's the same as sine of negative y. Okay, now, that means, see how I go if y equals inverse sine of negative x, then sine of y equals negative x. I'm going to do that now. So if x equals sine of negative y, then the inverse sine of x is negative y. Taking the negative to the other side, y equals negative sine of the inverse of x. So therefore, we've just proven the result, that the inverse sine of negative x equals the negative inverse sine of x. Okay, so that was the proof. You just got to learn the rule. In other words, if you're doing the inverse sine of something in quadrant 4, you're going to get a negative. And we were doing that all in the last exercise. Right, there's another rule. So girls, it's very similar to the normal, you know how we know from normal trig, not inverse trig, but normal trig, what's sine of negative x? Negative sine x. So in normal trig, sine of negative x is negative sine x. Do you remember that? in ordinary trig functions. In ordinary trig functions, do you remember that from when we did trig? We were just talking about it up there. Sine of negative 30 is negative sine 30. So in ordinary trig functions, sine of negative x is negative sine x. Well, guess what? The function, the same property applies for inverse trig functions. That's how you will remember it. For inverse trig function for sine, same property. Inverse sine of negative x is negative inverse sine of x. All right, let's do it with tan. Does it work for the tan function? Like, let's think of the normal trig functions for tan. Trig functions, what's the tan of negative x? That's talking quadrant 4. Is tan negative in quadrant 4? That's negative tan x. Let's see if we get the same thing for inverse trig functions. So, next rule. That was the first one. It's good when it works for both. Inverse tan of negative x equals negative tan of the inverse function of x. We're saying yes, it's going to work. Let's prove it. Proof. Start with the left-hand side. Let y equal the inverse tan of negative x. Therefore, what do you think I do next? Every time I let alpha equal inverse tan of something, what's the next step? Tan y is negative x. Look what we did before. What do you think I'm going to do? I'm up to here. Yep. X is negative tan y. Then I'm going to use this rule for normal tan functions. What do you think I'm going to do? X is the... If negative tan y is the same as tan of? Tan of negative y. And now I'm going to do the inverse tan. So inverse tan of x is, taking that basically, is what? Is negative y. What am I going to do next? Make y, swap sides. Negative inverse tan of x. That's proven. So therefore, the inverse tan of negative x equals negative inverse tan of x. Same as the normal function, same property holds for the inverse function. All good? See, you'll use this if you're asked to do an inverse tan function proof. And you've got inverse tan of negative x. Well, you can change that and write it as negative inverse tan of x. Okay? No, probably not. Look, no, I don't think you'll be asked to do them, but it's good to know the processes in case you've got some other question where you need to use these ideas. All right? Last one. Let's hope the rule is the same, and I think it's going to be. For normal cosine functions, for normal trig functions, normal ones, no, not going to work. Well, it does. It's like the general solution one. When you do the general solution of a cos function, normal trig functions, cos of negative x, isn't that just cos of x? Normal trig functions. But normal trig functions, when you're doing general solution, no, that is true, because in quadrant 4, because cos is positive in quadrant 4, that holds. But this is not going to be the case for our trig functions. Why do you think I'll never go to the negative? Well, it's got to lie between 0 and pi. Inverse cosine functions lie between 0 and pi. We're more than likely now going to quadrant 2. That's where you're going to find your negative cos, in quadrant 2. And quadrant 2 is pi minus. All right, so, oh yeah, this is, yeah, we'll just leave it at the moment. That's actually got nothing to do with what I want to do. Yeah, forget that one. All right, let's look at this one. The third one, the inverse cos of negative, that's a negative x, equals pi minus the inverse cos of x. That's my rule. Girls, that's a negative. So it's different to this, different to the ordinary function. All right, let's start. Let y equal the inverse cos of negative x. What's next? cos of y equals negative x. Of course, this is for 0 less than or equal to y less than or equal to pi, for y lying between that. Because, you know, for an inverse cosine function, it looks like that. Pi and 0, all right? What am I going to do now? What did we do before? X is negative cos y. All right, that is not quadrant 4, okay? That is what? It's 2 or 3, and we always go with the smallest, which is 2. So that's the same as pi minus cos of, no. This is the same as cos of pi minus y. Why? Because, for example, if you've got negative, because I'm talking, oh God. That's, yeah, it's, yes, but also because if you've got, say, negative, if you've got negative a half, x is negative a half, one sec, then isn't that, wait, I'd rather, maybe I should write, yeah, let's go back up here. If cos of something is negative, we're talking quadrants 2 and 3, okay? Now, with quadrants 2 and 3, with quadrant 2, it's pi minus, and with quadrant 3, it's pi plus. But because the y has to lie between 0 and pi, we're using pi minus, okay? Now, why do I have brackets here? All right, yep, just one sec. But I'll show you why it's going to be that in a minute, because we're going to do cos to the minus 1 of x is pi minus y. One sec. This, let's say we had negative cos 60. That is different to cos of negative 60. So let's say y is 60 degrees. Negative cos 60, it's the negative of cos 60. That would be either, the answer you would get would be either in quadrants 2 or 3. Because it's negative a half. We take the quadrant 2 angle because that is within the range of the inverse cosine function. So quadrant 2 is always 180 minus or pi minus. So that is the same as cos of 180 minus 60, which is 120, or pi minus whatever that angle is. All right? Now, x is cos of pi minus y. The inverse, so therefore inverse cos of x is pi minus y. Which means that y, let me make y the subject. What is it? Pi minus inverse cos of x. Done. So therefore, inverse cos of negative x equals pi minus the inverse cos of x. Last rule. All right, in other words, you're going to quadrant 2. Pi minus, always quadrant 2. If you think of this, yeah, you're not allowed here to go to quadrant 4, because you're not even allowed to talk about inverse cos of negative x, because that's in quadrant 4. You're not even allowed to talk about it. So you need to move that quadrant 4 thing. It can't apply at all. Okay, and that's why we go to quadrant 2, just like we do in general solution. All right? This rule is really important. The inverse sine of x plus the inverse cos of x equals pi on 2. You know what that is, girls? In a right angle triangle, if you call one alpha and you call the other one beta, in a right angle triangle, they equal 90. Look, that's what that rule is. I'll show you. This is the rule that we're trying to prove. Inverse sine of x plus inverse cos of x is pi on 2. You know how we always let alpha equal inverse sine of x and let beta equal, actually that's not the proof, that's not how it goes, but I'm just going to show you something first. Beta equals inverse cos of x. then sine, you know why it's not going to work, girls? I'm in different triangles. I'm not allowed to draw the one triangle with alpha and beta, am I? Girls, I'm not allowed to. Different triangles. So forget that one. You're not allowed to do it that way. So we're not going to do it that way, but they will end up being. So we're going to start again. Let y. Did you see why I wasn't allowed to do that? If you've got alpha and you've got beta, you've got to be. But if I actually do them all, if I proceed down that method, I'm going to find that this angle is going to be the same as that one anyway, if I do this. It will end up being the same. So, I think. So let y equals sine to the minus 1x. What's next? Therefore, what have we got? Sine of, proof, y equals x. Or x equals sine of y. This is for, remember y has to lie between negative pi on 2 and pi on 2 for the inverse sine function. Sorry about the wrong track. Y equals inverse sine of x. Sine of y equals x, so x equals sine y. This is our restricted range here for y. Negative pi on 2 to pi on 2, because that's the inverse sine function. Now, sine and cosine are complementary angles. So therefore, x equals, what's sine of 10? Cos what? 80. Sine of 30 is the same as cos 60. So therefore, that will be cos of what? 90 minus y. Pi on 2 minus y. So therefore, inverse cos of x equals pi on 2 minus y. Now let's replace, so let's just make y the subject. No, maybe. Yeah, it doesn't y equals sine to the minus 1 of x. So therefore, cos to the minus 1 of x equals pi on 2 minus, substituting back in the y, sine to the minus 1 of x. And now let's take sine to the minus 1 of x over to the left. Sine to the minus 1 of x plus cos to the minus 1 of x equals pi on 2. And that's the result. All good? That one you should know. Because you're often asked to do it with numbers, like with values. Note, since therefore this is an odd function. That's all. And we spoke about this because function of minus x equals minus function of x. Function of minus x equals minus function of x. So therefore, the inverse sine function, so therefore, inverse sine function, no. I just want to say that the inverse sine function is an odd function. Inverse sine function is odd. Why? Because I've got it there. Function of minus x equals minus function of x. Can you see that? What about the inverse tan function? Is it odd? Yeah. Yeah. So y equals tan to the minus 1 of x is also an odd function. So inverse sine function is odd. Inverse tan function is also odd because the function of minus x equals minus function of x. But you can tell if it's odd or not because of the drawing of the function. If you rotate this 180 degrees about the origin, you end up there. Each point ends up on the other side of the origin. If you want to physically do a rotation of 180 about the origin, you actually get a ruler and you might say, right, that's 2 centimetres from the origin. Let me measure 2 centimetres down here. That's the matching point. That's how you do odd functions, rotating them about the origin. 180 degree rotation is a straight angle. So if you've got a ruler here and that's 2 centimetres up there, on the same straight line, that's 2 centimetres down there. Let's say you've got a ruler through here and that's 1 centimetre over there. The matching point over here is 1 centimetre over here. That's for odd. Now the inverse tangent function is the sideways one that looks like this, where this is negative pi on 2 and pi on 2. So if I want to find the matching point for this here, I get my ruler. Let's say that's 3 centimetres. 3 centimetres down here is the other matching point. That's how you do odd. That's how you... Cos is not odd. I'll show you why. Cos is not odd because... No, neither. Cos is not odd nor even. Here is cos. Look at it. If I rotate that point about the origin, I should have the other part of the graph down here. That part of the graph should be over there, matching. This should be down here. So the inverse cos function, if it was even, it would be symmetrical about the y-axis, and it's not. So the inverse cos function is neither odd nor even. You're allowed to have neither odd nor even. Girls, that's because cos of minus x does not equal minus cos of x, and inverse cos of minus x does not equal inverse cos of x.